let's go ahead and get started with some guided notes. The first part of this packet is going to feel a little bit like review, but I figure that's a good thing because I haven't seen you guys in over a week. We all had plenty of time to go home or go on vacation and forget everything we knew about algebra. So it might not be a bad idea to review a little bit here at the start. So the title of the topic that we're going to be talking about this week is standard form / factored form. But the title is actually a little bit longer than that. It's standard form of quadratic equations and factored form of quadratic equations. So if you look at this table that I have here, this sort of grid, we have a blank box underneath standard form of a quadratic. And I just want to remind you what that looks like. A quadratic equation is written in the form y equals ax squared plus bx plus c. That is the standard form of a quadratic. And just keep this in mind. You're not going to come across quadratic equations with a's and b's and c's in them. Okay, these will be numbers. So it might be something like y equals 4x squared plus 3x plus 9. So these will be numbers, not a, b, and c. But it will be written in this format where you've got three separate terms that are separated by pluses or minuses. Your first term has an x squared. Your second term has an x. Your third term just has a number. So it will look very similar to this, except instead of a, b, and c, you have numbers. So what's the deal with the standard form of a quadratic? Why do we use this? What is it good for? This form is very helpful when we need to know a, b, and c. Go figure, right? A and b and c are numbers that are very clearly easy to pick out in a standard form of a quadratic. And we use those in a lot of situations when we need to identify key features of a quadratic function. For instance, if we want to find the axis of symmetry of a quadratic, I know it's been a long time, but does anybody remember the formula that we use to find the axis of symmetry? It's been a while, so no pressure if you don't remember, but if anybody does remember, I'd love to hear it. It starts like this. X equals negative b. Yes, negative b divided by 2a. So it's been a while. We talked about this, maybe 3 weeks ago, and then again 2 weeks ago, but we had all that time over spring break to forget it. The formula for the axis of symmetry is x equals negative b over 2a. Well, the b and the a that we're talking about in this formula comes from the standard form of the quadratic. You have to go up here and figure out what a and what b are equal to, and that's how you know what to plug into your formula to find the axis of symmetry. So it's a lot easier to find the axis if we have our quadratic already written in standard form. Well, the vertex is very similar to the axis of symmetry. If you remember, the vertex and the axis of symmetry have a lot in common. So the axis goes right down through the middle of the parabola, and the vertex is also right in the middle of the parabola. So the x value of the axis matches the x value of the vertex. So if you want to know the vertex, remember, is a point, x comma y. The x value of your vertex is the same as the x value of your axis of symmetry. So the x value of your vertex is negative b over 2a. And the y value of your vertex is something we have to find after we've already figured out what x is. So to find the y value, you plug the x value in to the equation to find y. That's how we find the y value. So we're just taking some kind of basic notes here. This is not super precise. We're just jotting some ideas down to remind us what these concepts are. All right, so the last thing that the standard form will help us find is the y-intercept. And this is another one. I don't necessarily expect you to remember this because we haven't talked about it in 2 or 3 weeks. But when we want to find the y-intercept of a quadratic, you have to plug 0 in for x. Well, if we put 0 in for x, don't write this down, I'm going to erase it. If we put 0 in for x here and 0 in for x here, then we end up with 0 plus 0 plus c. So our y-intercept is always just c. Our y-intercept is that number that's down there at the end. So we learned a little shortcut. Your y-intercept is the point 0, comma c. And we don't even have to think about this too hard anymore. We just look at our standard form, we find the number c at the end, and we automatically know that that's our y-intercept. So A and B and C can give us very quick and reliable information about the y-intercept, the axis of symmetry, and the vertex. But the standard form gives us no information about roots, x-intercepts, solutions, and zeros, right? And we talked about those before spring break, but for these, we want to use a different form of a quadratic function. So write this down. The factored form of a quadratic equation looks like this. Y equals parentheses x minus h, close parentheses, and then a new set of parentheses, x minus k, close parentheses. The parentheses are very important. You need those there. And I also want to point out the h and the k, don't think too hard about these. These are just some random letters that we picked to put in here. This is just like the A and the B and the C. These will not be H's and K's when you're actually dealing with functions. You will have numbers here. So it might be like x minus 5 times x minus 2. So you'd have numbers in those positions. And the reason we care about the factored form is because the factored form is very helpful when we want to know roots. And maybe you guys will remember last week in class we did a Kahoot together where we did like 20 questions in a row where we had functions that looked like this and we had to find the roots. And you guys were so fast. You were answering those questions in like 5 seconds because we found a little pattern. Here's the pattern. Our roots are going to be at x equals h and x equals k. Those are our roots. So when our function is written in factored form, it is so easy to pick out the roots. You just find this number here at the end, you change the sign from a negative to a positive or from a positive to a negative, and all of a sudden you have your roots. Now don't forget, roots and solutions are the same thing. They mean the same thing. So our solutions would be x equals h, x equals k. And roots and solutions are the same things as x-intercepts. So these are also the x-intercepts, but before you get to writing it, we'll write this in a different format this time. When we're talking specifically about x-intercepts, we usually like to write our answer as a point. So yes, the x values are going to be h and k, but the y values of these points would be 0. So our x-intercepts, it's the exact same thing. It's the x equals h and the x equals k, but we would typically write it in the form of a point, h comma 0 or k comma 0. So what do we know so far? We know that we have these 2 different forms of a quadratic, and we know when the standard form is more useful, and we know when the factored form is more useful. But how could we potentially go back and forth between these 2 forms? Let's first imagine we start off with an equation that's in factored form. Can we convert that into standard form? And if your eyes drifted down a little bit, you'll see that we can. To go from factored form into standard form, we just have to multiply the factors together. So that would be like if I had 5 times 3 and I changed it into a 15. 5 times 3 is the factored form. That is two factors being multiplied together. By changing it into the 15, you've multiplied them together, you've turned it into the standard form. So factored form into standard form. This is the process that we're going to be doing. But it's a little bit more complicated because we don't have 5 times 3. We've got a bunch of stuff involving x's and x squareds. So what we're going to do is basically just jump into an example and see how this goes. We want to rewrite a factored quadratic in standard form. In order to do that, we're going to have to multiply the factors together. So specifically, we will multiply x plus 3 times x plus 5. Now, these are guided notes. These are your notes. So you might want to write this down in your notes so that later, if you're trying to remember what you did to solve this problem, you can go back and see this in your notes and you'll remember what you did. So this is our step. We're going to multiply x plus 3 times x plus 5. But things get a little complicated here because we are multiplying something that has two pieces by something that has two pieces. So here's how we're going to do this. Our first factor has two pieces. So we're going to set up a grid that has two columns. And our second factor has two pieces. So our grid is also going to have two rows. So it'll just look like this. Kind of looks like a window pane. It's a 2 by 2 grid because we're multiplying something that has two terms by something else that has two terms. We're going to label the top of our grid with the x plus 3. And then we're going to label the left-hand side of our grid with the x plus 5. Oops. Now, in each of the individual cells of our grid and each individual pane in the window, we are going to figure out what's above it and what's to the left of it and multiply those two things together. So for instance, let's look just in the first box. So top left corner, just in this square. To figure out what goes in here, we're going to multiply what's above it times what's to the left of it. So we'll be taking x times x, and that's what we put in the box. So off to the side, I'm just going to write this kind of on scratch paper, but I'll erase it. What is x times x? X to the second power, x squared. And it might help to think of it this way. If this is x to the first times x to the first, so when you multiply them together, you add your exponents and you get x squared. Another way to think of it is anything multiplied to itself is just squared. If I said 9 times 9, that would be 9 squared. So inside this box, this top left corner, we write x squared. Now let's do the same thing for the box on the top right. So now we're looking at this panel, this pane, and in order to fill this in, we're going to be multiplying together positive 3 times x. So positive 3 times x. 3 times x. And here, the 3 and the x cannot combine. You know, they don't multiply together really because they don't have the same base. So all we do is we just have to write it as 3x here in this box. Now for the bottom left, in this bottom left pane, we're going to be multiplying together positive 5 times x. Positive 5 times x. Well, positive 5 times x, the number and the variable can't really combine. So we just have to write it like that. We just have to leave them separate and write it as 5x. And finally, on the bottom right, to fill in this part of our grid, we're going to be multiplying together positive 3 times positive 5. Now, don't let these plus signs confuse you. We are not adding, we are multiplying. This whole process is a multiplication process. So we're multiplying positive 3 times positive 5. So down here in the bottom right, we get positive 15 in that box. Okay, so we did all of that work, but now all we're looking at is this weird square. Well, we're not really done. This was a tool that we used to help us keep our multiplication organized, but now we need to put this back into our equation. So what it looks like is we always had the y equals part. That comes from here. But then the rest of it, the x plus 3 times x plus 5, has now become all of the stuff that's inside the box. So we'll take the 4 terms that are in those boxes and we will rewrite them with plus signs or minus signs between them. These all happen to be positive, so we'll have positive x squared plus 3x plus 5x plus 15. So we're just rewriting what's in the box outside. And finally, we always want to make sure our answers are simplified. Take a look at these 2 terms here in the middle, the 3x and the 5x. Those are like terms. They have the same exact number and type of variable, x. You know, the x's don't have any exponents or anything like that, so they're exactly the same. So we can add those together. When we combine them, we only add the number in the front. So we take 3 plus 5, which gives us 8x. So we end up with x squared plus 8x plus 15. And that is our standard form. Just a hypothetical question for you. In this example, once we've turned this from factored form into standard form, it should be really easy for us to find A, B, and C. Can I get any volunteers to tell me what they think A and B and C are equal to? What about, let's start with B. B should be the number in the middle. Yeah, so this is our B, and C? Yeah, that's our C. A is a little trickier. Do you have any thoughts on A? Yeah, there's no number there, so we would just pretend like there was a 1. So yeah, A, B, and C. So you can see how going through this work, which usually doesn't take that long, can actually get you into your standard form where you can very quickly identify your A, your B, and your C. And then you can use that to find your y-intercept, your vertex, whatever you need. So let's try example 2. Example 2 is very similar to example 1, except this time we've got some negatives thrown into the mix, so it might complicate things just a bit. Let's read our goal. We want to rewrite the factored quadratic in standard form. So in order to do that, we need to multiply the factors together. Or more specifically, we need to multiply x minus 4 times x plus 1. So this is where my rectangle comes in. I'm going to be multiplying a 2 by 2. So I'm going to make a box that has 2 columns and 2 rows. And along the top, I'm going to put x minus 4. And along the side on the left, I'm going to put x plus 1. Notice that that 4 is negative. That's going to affect things, so pay close attention as we're going through the various pieces of this problem. All right, on the top left, we have x times x. As we discussed in our last example, x times x gives us x squared. On the top right, we have -4 times x. -4 times x gives us -4x. It's as easy as that. Bottom left, we'll have +1 times x. +1 times x gives us +1x. And no, you don't have to write the 1. And finally, on the bottom right, we have +1 times -4, which will give you -4. Okay, so now we rewrite our equation in standard form, which is y equals the 4 terms inside our boxes. So x squared minus 4x plus 1x and minus 4. Notice the positive signs and the negative signs. If you ended up with a negative in one of your boxes, you'll have a minus. If you ended up with a positive in the box, you'll have a plus. And our last step is always to see if this can be simplified. I have 2 terms in the middle here that are like terms. And get used to this happening. This will happen in the vast majority of problems. The 2 middle terms will end up combining because they will be like terms. And when you combine them, make sure all you're doing is adding the numbers in the front. -4 plus 1 gives us -3x. So we end up with the standard form, y equals x squared minus 3x minus 4. And this, of course, is perfectly equal to what we started with. They are exactly the same. They're just written in a different form. All right, we've got a couple more examples like this. Example 3, I'm going to start moving a little bit quicker now. We are dealing with the same goal. We want to rewrite our factored quadratic in standard form. So to do that, we need to multiply the factors together. So we're going to multiply together x minus 6 and x minus 5. Another tricky negative problem. Just make sure you're watching those negatives because there are going to be a lot of them floating around this time. Across the top of my grid, I'm going to put x minus 6. And down the left-hand side of my grid, I'm going to put x minus 5. In my upper left box, we get x squared. Upper right, we get -6x. Bottom left, -5x. And bottom right, pay close attention to those negatives. We get -6 times -5, which multiply together to give us a positive 30. Positive 30. I see some erasers going. It's an easy mistake to make. Okay, so now let's rewrite this as a quadratic. Y equals x squared minus 6x minus 5x plus 30. And as we're hopefully starting to get used to by now, we notice the 2 middle terms are like terms. So we can combine those together into a single term. Again, I'll caution you about the signs. It's a -6 and a -5. So when we combine those, we end up with a -11. So we get x squared minus 11x plus 30. All right. Example 4 is trickier because I threw something at you we haven't seen just yet. So even if you're starting to feel pretty confident with the process that we're using right now, number 4 might throw a bit of a curveball at you. So pay close attention to this one. We have the same goal, so we're going to use the same process. Multiply the first factor, 2x plus 3, times the second factor, x minus 2. So to do that, we're going to set up our grid, our rectangle. And across the top, I'm going to write 2x plus 3. And down the side, I'm going to do x minus 2. It's the upper left box that has me a bit concerned. So to fill in the top left box, we're multiplying together 2x times x. I know we might sometimes get a little bit ahead of ourselves, and we're so used to the upper left corner always being x squared, we might just want to write x squared and move on. But you actually have to look at this one. This is not just x times x. This is 2x times x, so it's going to change things. Now, the way I wrote this out makes it look like the 2 is connected with that first x in a way that is unique, but it's not. You could just look at this like 2 times x times x. And it's not the 2 that combines, it's actually the x's that combine together because they have the same base. So these two x's multiply together to give you x squared, and the 2 that's out front doesn't connect with anything. It just sits there. It doesn't combine at all. So what we end up with here in our top left box is 2x squared. Now for the rest of the grid, on the top right, we have 3 times x, which is 3x. On the bottom left, we have 2x times negative 2. Again, pay close attention to this. 2x times negative 2 is the same as 2 times negative 2 times x. We can put them in a different order. And it's the 2 times the negative 2 that will combine. The x just kind of hangs out there by itself because it doesn't have anything to combine with. So we end up with negative 4x in the bottom left. And finally, on the bottom right, we have 3 times negative 2, which will give us a negative 6. All right, now it's time to put all of this into our quadratic equation form. So we will write this as y equals 2x squared plus 3x minus 4x minus 6. And we combine our middle terms because they are like terms. So we get y equals 2x squared minus 1x minus 6. Notice the positive 3 and the negative 4. When we add those together, we get negative 1. Okay. Guess I can highlight the answer to be consistent. In our last example, we're asking a very different type of question. We are given a quadratic written in what form? What form is this given to us in? In the last example at the bottom of the page, what form is this? Say that again? Quadratic form. Well, it is a quadratic formula, but is it standard or factored? It is factored form. What does factored form help us find? Does it help us find vertex? What features of a quadratic does the factored form help us find the best? It's right there on the top of your page. Gigi, can I get you to help me out? Look at the top of your page. The factored form helps us find what? What features of a quadratic? The roots. Thank you. So in this question, we have a factored quadratic and they want us to find the roots. So that's convenient. They're asking us to find the roots and the y-intercept, and the vertex. Well, the roots are easier to find if we have our equation in factored form. But the y-intercept and the vertex are easier to find if our equation is in standard form. We start out in factored form. So at about the midpoint of this problem, we're going to have to switch gears and we're going to have to convert it into standard form to actually figure out the rest of the problem. So let's start first. We have it in factored form already. So let's answer the question about the roots. Because we already have it in factored form, we should be able to pretty easily pick out the roots. So let's take a stroll down memory lane. We talked about this the week before spring break. In order to find the roots of an equation, you have to set that equation equal to 0. So we will take this factored quadratic and set it equal to 0. That's where the roots come from. Now, you don't necessarily need to write this down, but I need you to think about it. If we have two factors being multiplied together and it equals 0, what does that tell us? We have something times something else, and that equals 0. What does that tell us about our factors? Two things that are multiplied together to give us 0? Milani, would you be able to help me out here? If two things are multiplied together and it equals 0, does that tell us anything important about the things that we're multiplying by? One of them has to be 0. Exactly right. We are multiplying by 0. That's the only way that two things can multiply together and be 0, is if one of them is 0. Thank you, Milani. So we don't know which one, but one of these factors is 0. So what we do is we split this up into two cases. I'm going to use that color. We split this up into two cases. The first case is, okay, well, maybe it's 2x minus 1 that equals 0. Maybe it's the first factor that equals 0. Or the second case, maybe it's the x plus 3 that equals 0. It could be either one. And frankly, it doesn't matter which. It could be both of them. So these two separate mini equations are now going to yield two different roots, two different answers, two different solutions. So we're going to solve each of these for x, which shouldn't be that bad. On the left, to solve this one for x, we need to just add 1 to both sides, which requires us then to divide both sides by 2. So when I do that, I end up with x equals 1/2, or 0.5. It'd be fine to express your answer as a decimal. All right, so now on the right, this one's even easier. To get this x by itself, we just have to subtract 3 from both sides, and you end up with x equals -3. So we got two answers. Our roots are x equals 1/2 and x equals -3. And we got those roots by using the factored form. Now we want to find the y-intercept, but I've already spoiled the fun for you. We know that finding the y-intercept is way easier to do if we can write this in standard form. So before we even get to the y-intercept, we need to take some time to just convert our equation into standard form. And to do that, we'll use the process that we used on example 1, example 2, example 3, and example 4. So that process is multiply the two factors together. So it's multiply 2x minus 1 times the x plus 3. And that's where our grid comes in. our 2 by 2 rectangle. And across the top, I'm going to put 2x minus 1. And down the side, I'm going to put x plus 3. So in the box on the top left, I end up with 2x squared. On the top right, we end up with negative 1x. On the bottom left, we get 6x, positive 6x. And on the bottom right, we get negative 3. Remember, we're multiplying to fill in these boxes. And once you've got all your boxes filled in, you can convert this into a quadratic equation in standard form. So we'll just write our 4 terms, 2x squared minus 1x plus 6x minus 3. And our 2 middle terms are like terms. Get used to that. It'll happen in almost every problem. So when we combine those, we add the numbers in the front. Negative 1 plus 6 will give us a positive 5x. So we end up with the standard form quadratic 2x squared plus 5x minus 3. So we just put this into standard form. Why? What's the point of that? Well, just remember what we're trying to find. We're trying to find the y-intercept, and we're trying to find the vertex. So our y-intercept is, if you look up at the top of your page, I reminded you the y-intercept is 0, c. Jaden, you're my trusty ABC guy. Can you help me figure out what c is? C is negative 3. So my y-intercept is 0, negative 3. Very good. Now it's time to find the vertex. For our vertex, we have a formula. Our formula is that the x value of the vertex is equal to negative b over 2a. And that's up in your notes at the top of the page if you forget. You can always come back and look at your formula. You look at your standard form. This here, what is a and what is b? So we're looking at this standard form. And Jaden already found C for us. Can you find A and B? Perfect. So it's just the numbers in the front. Whoops. We're not looking at the x's themselves. We're just looking at the numbers. So A is 2, B is 5, and C is negative 3. So let's go back to our vertex. To plug in negative b over 2a, we need to take our b and put it in. We need to take our a and put it in. So let's see. B is 5, A is 2. So that's going to give me negative 5 over 2 times 2. Notice that the A value and the B value are in parentheses when I plug it in. That's always necessary, very important. And you end up with, when you simplify this, negative 5 over 4. Feel free to punch that into your calculator and you end up with a decimal number. That's okay. When you're doing problems like these on a quiz, you'll have multiple choice answers. You can either leave your answer as a fraction or convert it to a decimal, depending on what type of answer they are providing to you in the multiple choice. So this is the x value of our vertex. We can even come up here and start to write our answer. So our x value is negative 1.25. But now we need to find the y value. And hopefully you made a little note at the top of your page today that helps you remember how to find the y value of your vertex. The x value is negative b over 2a, but the y value, we have to find that by plugging our x value back into the equation. So we take our equation, y equals 2x squared plus 5x, what was it? Minus 3. We take this equation and we're going to plug negative 1.25 in for x here and here. So that'll be 2 times negative 1.25 squared plus 5 times negative 1.25 minus 3. And I like what I'm seeing. I see a few people with calculators in their hands. That's exactly what I plan on doing here. I'm not going to do this in my head. Make sure as you're typing this in that you're really careful and you put all the parentheses in the right place. You get the negatives in the right places. Punch this in very cautiously. And I want to know what you got. That's exactly what I got. Anybody else get that? Negative 6.125? Awesome. Okay. We are improving with our calculator skills. Negative 6.125. And you can round that a little bit. That's fine. So that's the y value of our vertex. And I've got a very multicolored answer sheet here. But does everybody see the process we went through? We started out in factored form. We got the information from that we could, namely the roots. And then once we were done with that, we were like, okay, well, we need to put this into standard form now to get the rest of the information. And so we did this whole step down here. This entire step that I put in the corner in green, this was not part of the problem. The problem did not tell us to do this. It was not in the instructions, and technically it was not even necessary. We did that to make our lives easier, because it's more convenient to answer some of the questions about y-intercept and vertex if we can put it into the standard form. So this was extra work on our part that ended up saving us work later. So that's what these forms are, converting back and forth between the different forms. It's a convenience thing. And so what we're going to be working on this week is trying to figure out when we need to use which form and how to go back and forth between the two forms. So today we practice going from factored into standard. Later in the week, we're going to learn how to go from standard into factored, which is significantly tougher, but also way more fun. So we have that to look forward to.